Hello, welcome to another edition of Bits and Bytes Live, the short series of conversations that we have here at VMware, looking at topics of interest through the lens of the communication service provider. We're going to continue our conversations around sustainability in this particular broadcast. Last broadcast, we talked to Lorcan Burke, and we were talking about some of the principles to follow on sustainability. We talked about embracing virtualization and containerization as a way to further advance the ability to drive sustainable networking, adding instrumentation to that to get the visualization of what was happening in your network, but doing so from a sustainability angle, whereas in the past it might have been performance or cost or other things. So adding in that to the way we look at the network, developing our automation to make changes in the network in response to what we see. And the topic we're going to talk about today, which was to look at leveraging more green or clean or carbon sensitive energy. So that's what we're going to focus on today, is looking at that use of green energy. My name is Nigel Stephenson. I look after market development for our Telco BU here at VMware for Europe, Middle East and Africa. And to talk about this topic, I'm joined by Valentin Bondzio. Welcome, Valentin. Valentin is actually our customer sustainability architect, and he works out of the office of the CTO. So a lot of technical experience and know-how to bring to the party. So thanks, Valentin, for joining us. Appreciate that. As I say, we're going to talk about the use of leveraging more green energy. So we'll talk about how to use less energy actually in our next broadcast. So this is about saying, for the energy we do use, how can we make sure that energy is as green and clean as it can be? So that's the topic of the conversation. To start it off, Valentin, if I can ask you, what is the landscape we're looking at here, and how do we, how does energy arrive to us? What does it look like? Some is greener than others. What does that mean? It's greener or it's not so green? Explain me.
So first, I see you will have noticed that I'm wearing my green shirt for the occasion. I noticed halfway through that I can't use my green screen because then I would be a floating head. So I'll figure I'm going with a broad background today. Yeah, but green energy is, the grid is usually a markup of all of the electrons that flow into it. Like imagine a swimming pool. Like the water molecules really don't tell you whether they come from the rain or sewage, right? So a water molecule is a water molecule, an electron is an electron. So the grid is usually a mix of different types of energy depending on the day and depending on the source and the intensity. For example, if the sun is shining a lot, then there might not be any fast reacting so-called peaker plants that have to contribute carbon intensive energy to the grid. So you basically have a mix of energy in the grid at all times. So you don't really know what you're getting for most regular consumers.
Right. Well, that was my challenge. I'm thinking I am a regular consumer, and I have to be honest, and I don't know in any sort of detail, and I certainly don't know by time of day how green or otherwise my energy source might be. So what are the options available to organizations in terms of understanding the energy that they are either using or could potentially make use of? How do they get to know or categorize how clean that energy is?
So there's certainly services on a per country basis like WattTime Electricity Map and others that you can procure more regular data from, where you can see approximately what the carbon intensity or the makeup of the grid is at the time of day. Now, the granularity differs between different, let's say, paid offerings. Some grids are a little bit more open about their markup. If you are a large consumer of electricity, or if you are in good contact with your data center, and they have, let's say, certain power purchase agreements, then your markup actually might differ from the grid, but the best information usually comes from these who consume the most, right? If you don't get it from your grid, you might be able to get that information from your data center, who usually have a great relationship because they burn through a lot of energy.
Right. So actually, the information may well be within the organization, but the person who's looking at it from a sustainability strategy point of view may need to go around and find the people with that information.
Yeah, so sometimes the facilities and that org can have contacts to energy providers already now, but usually offices do not consume as much as data centers. So unless they're under
Right.
your own control, it probably would be best to talk to whoever is doing that for you.
Okay, cool. And we've got visibility to at least a certain degree of the makeup of the energy that we're either using or have potential to use. So how can any organization make use of this? I mean, I'm thinking, if I happen to have a data center next to a wind farm, I'm probably in a really good position, but maybe I don't.
Yeah.
How many organizations realistically can make use of strategies towards green energy?
In theory, everyone, depending on type. But let me just say, if you're next to a wind farm, that doesn't mean you're getting green energy. The electrons might arrive at you, but someone else might have the right to
Sure.
claim these electrons, right? So there are things like EACs or RECs, energy attribute certificates in Europe, or power purchase agreements where someone else has a right to that renewable energy. So you can't really just go based on locality here. Again, it's a big swimming pool. But
Right.
apart from that, if you're a large consumer of energy, right, then certainly maybe your data center provider already has a power purchase agreement, right? Or maybe you're a large enough consumer that you can go into negotiations for EACs directly with the grid provider or other organizations. So VMware, for example, partners as a board member in CEBA, the Clean Energy Buyers Alliance, which is a good place to start. We also had a training video on how to actually do that in our cloud stream. It's a 7-part series that explains that process and the possibilities in way more detail than we would be able to cover here. But maybe we can leave a link to that later on.
And these, and just to be clear, I guess it's a developing field, but some of this instrumentation can be sort of ingested into the system, right? So we're not necessarily saying to somebody, look, watch this monitor, and when something happens, go and make some changes. We can automate this, yeah.
Yes, you can automate everything. Everything you can get data for on a regular interval can be automated, right? As long as you have the APIs to control that. And that's definitely something that VMware has been looking into.
Right.
If you remember at Mobile World Congress in 2022 and 2023, we showed a solution where we were steering traffic or workload based on the marginal carbon intensity of the grid surrounding that. So we've done this before in incubation states, and it certainly works. But there's a difference between steering towards greener region and steering towards more green, but we can get to that a little bit later.
Yeah, and that's a good point, actually. So that, because I remember that demonstration was really, really powerful, and what was happening there was, coming back to my earlier question, like who can make use of these strategies. That was very much based on sort of distributed data centers, wasn't it? So you had, if you knew a certain region of the world was at that time a better place to source energy, you could relocate workloads literally from one location to another geographically. So for that, obviously in that case, you would have to have that kind of an architecture. But
Yes.
presumably, if you're not, like, if you've got a single data center or very limited data centers, you've still got the ability to decide when to run a workload, right? So you could be doing it in time or space.
Yes, and I would just want to highlight, especially for the last use case, that it's not green or nothing, right? Or so green is just another metric that we use for these scheduling decisions. Obviously, if it's cross data center, latency plays a large role. Cost can be attributed, capacity can be attributed. Again, VMware does a lot of scheduling in many different places, whether it is at the host level, at the cluster level, or at the cloud level. So that scheduling just takes green energy as another metric, and obviously makes the right decision based on your based on how you want to weight these different criteria. But yeah, as you said, you can decide to run workloads at different times during the day. If you're looking at solar, for example, right? you often talk about the duck curve of solar energy, right? When there's a lot of solar production or even overproduction, right? The marginal intensity basically of the grid goes to zero. If you start a new workload, it would be consuming renewable energy at that state. In Ireland, for example, where I live, we have a lot of wind, and that wind sometimes blows strongest when everyone is sleeping. There are phases where Ireland curtails 30 to 40% of its wind energy, right? And if you have the possibility, if you have some of these workloads that are not latency sensitive or time sensitive, that can run throughout the night, that can definitely be scheduled and automated.
Okay, just like you might have done that because you had a different tariff overnight if you're a consumer user, you can do it because you know your energy is going to be more green if you do it at that time. So you can, and again, I guess that could be automated if you've got systems that actually give you real time type data. You could either automate it or you could simply do it on a time basis.
I have a colleague who has automated that already. Right now, my dishwasher is scheduled for 11 p.m. I have yet to integrate it into the actual power system, but yeah, it's certainly possible and
Excellent.
feasible.
And so, what? Just sort of closing out the whole topic here. Can you take us through some of the? We've already spoken about some of the ideas, I guess, but what are some of the tactical things people can deploy? People can actually go do, either possibly ideally today, but also maybe things you're thinking about in the future, techniques to use at the networking level.
Yeah, so we talked about changing load in time, right? I think that is fairly straight. That is not as straightforward. That's certainly something that takes scheduling and that takes automation that's in place. VMware is looking into that because we are a software company. We build a lot of software. Build processes are not only very compute intensive, but they're not always time sensitive. Some of these builds can be done throughout the night to schedule them during times of less carbon intensity. But I think what's more interesting is what could be done today. And there's a little bit of overlap, of course, with using less energy. One of the examples I like to highlight is disaster recovery as a service. I know so many customers that have dedicated failover equipment, not necessarily at twice the size. Sometimes they are prioritized for certain priority workloads and only at 20 or 30% capacity, but it's usually idle capacity. And we will talk at another time on how to optimize these during these times. But the best optimization, like in engineering, the best part is the part that isn't there. So if you don't actually have to have a disaster recovery environment, then obviously that would be beneficial. And if you use it, it would be great if you use it in environments that mostly use renewable energy. If you take VMware's disaster recovery as a service, for example, we'll deploy capacity into the hyperscaler data centers. And again, it is only there if you need it. Fingers crossed you don't. But if you do it, it's in fairly and highly efficient data centers that mostly run off renewables. And I just want to highlight here, yes, the hyperscalers are good about renewable energies, which is all where VMware SaaS solutions run, and they are power effective. That is not to say that your data center can't achieve the same or very, very close to that. Given some of the new regulations that come into place, especially in Europe, data centers have to have a power usage effectiveness value of 1.3. And I'm not sure about the year anymore, but it's in the next couple of years. So there are upgrades and efficiency improvements in place, and we're getting fairly close to that. So they're very good about it, but they're certainly no outlier.
And are there any other techniques that people can start using in the short term, or at least thinking about as part of their management mix?
Yeah, really, the best part is to schedule workloads that right now to the overall green energy is. Everything else would kind of fall under the bucket of reducing energy consumption. Like if you have a load shedding, for example, like it's not only that you increase the actual load when it's there, but it also means that you decrease it during other times. You basically flatten the curve. Well, I mean, we have heard flatten the curve a lot over the last couple of years, but it kind of fits here as well. So you kind of want to flatten the peak demand, because if you can avoid running during a certain time, you not only reduce your carbon effect, you not only reduce the amount of carbon you need for these workloads, right? But you also have the opportunity to run it later.
And you're right. I mean, these sort of pillars very much overlap. There's the using more green energy, but there's also using less energy, and sometimes the techniques actually look very similar. The overall goal is the same, but we try and compartmentalize them in order to strategize around them a little bit easier. And the other thing that comes into this, and I get it certainly comes into it when you talking of being more energy efficient, some of the things you touched on there is also for the telecoms environment is the risk element. So we'll talk about that, I think, in a subsequent episode when we get into looking at how you become more energy efficient, because in everything that we've been talking about, and especially if we start looking at things like disaster recovery or reducing overall power consumption, we have to be conscious of the fact that we might need that back very quickly. So there's, again, you mentioned there's lots of different metrics. Green is only one of them. One of those metrics is your service agreement that you're offering your customer. So there's a balance of these things that we need to take into account.
And maybe one thing I should have mentioned is, obviously, if you have the choice where to run, like our assumption here was that you run in your own data center, right? But if you're running, let's say, anywhere else, if you're running in one of our partner networks in our VCPP program, we have a specific cohort of our partners who have committed to be zero carbon by 2030. So that is the zero carbon cloud.
Right.
If you want to choose a more carbon effective way of running a workload in these partners, they're being highlighted on our VCP platform. So you have a choice of where you run sometimes, not always, but sometimes. If you have that choice, then you could certainly make that choice to run somewhere that is more carbon effective.
Okay, cool. So I think we looks like we've got a question coming in, but I can't see it as yet. Oh, here we go. So on the processor part, where we tend to use a lot of energy and generate a lot of heat, that's true. We can also use lower thread affinity and putting the disks to sleep more often. Use more compiled processors than interpreted ones, and it will come down significantly. That sounds very much like a statement that you can answer, Valentin.
Yeah, I think
I'm going to struggle.
Yeah, so this is this mostly fits probably in the more energy effective category,
Right.
because again, yes, if you have an option to obviously optimize your processes, yes, compilation can have an initial energy overhead and then has better energy efficiency during runtime, depending on how often you run that. Right, then there are can be some significant benefits. Anything you can do, obviously, is great to optimize that. Now, for heat generation, it's a whole other discussion on data centers with regards to how cool does a data center really need to be. I mean, if you remember data centers, if you've been in one, you probably remember cool air, right? We'll see how long that'll last, because, I mean, chances are that the air actually doesn't need to be that cool to still be effective. Lots of interesting discussions. Probably not the right spot in the green energy, because I think we have a couple more of these coming.
Yeah, indeed. And as you say, it's a huge topic. And even though we touch quite a lot of it from a technology point of view, there's a ton of things out there, like you say, the whole fabric of a data center that plays into this. So from a customer point of view, it's a very, very broad topic. And to a degree, from a VMware perspective, we're touching a reasonable amount of it, but there's a lot of aspects to energy saving that go way beyond what we can do in software, I think. But we can hit a fair bit of it.
Oh yeah, and definitely watch this space. This is something that, as you've maybe seen historically with VMware, have looked into, and if you have talked to me or Nigel at a Mobile World Congress, then you will have already a little bit more of an insight into what we're planning there. But certainly watch this space.
Yeah, absolutely. There's ways we can start interconnecting some of these systems in ways that people might not have envisaged, because frankly, we never had the motivation before. Now, especially in Europe, we've got a big motivation. We want to do good stuff. That's always been part of our ethics. But there's a business case behind this as well right now with energy costs as they are. So yeah, it's actually interesting that I think the innovation is really growing, and the sort of lateral thinking as to how we can interconnect some of these systems that traditionally we wouldn't have thought of connecting, but things like data center cooling with some of the things that happen in workload placement or whatever. So yeah, very interesting time. Well, look, I think, I mean, we've covered a lot there. As I say, these are short conversations, hopefully about the length of a cup of coffee. So if you did grab a cup of coffee before we started, you're probably towards the end of it now. Thank you, Valentin, very much. Do appreciate that.
Thanks for having me.
I think you're going to join us on some future ones as well. And as I say, we are going to look at the energy efficiency aspect, I think, in the next session. So we've talked about how we can visualize and make use of greener, cleaner energy as much as we can. But the other side of this coin is to just simply try and use less. So that's the topic for the next conversation. For now, Valentin, thank you very much indeed. Much appreciate you and your green shirt.
Thanks for having me.
And for those watching, thanks for watching, and we'll see you next time.